Okay, guys, we're going to start a new unit here. It's on quadratics. This is one of the most important, or let's say relevant topics that we're going to learn in Algebra 2. Okay, we're going to study quadratics, which is anything that has a largest exponent of 2 attached to the variable. All quadratics come in the form of parabolas. So I'm going to give you a quick introduction of just things to know about quadratics and parabolas. Today we are going to learn one thing. It's one form. It's called vertex form. It relates to our inside-outside rules. But let's just talk about what a parabola looks like in general. All parabolas are in the shape of a U. Okay, they're all in the shape of a U. They could, of course, be in the shape of an umbrella, which is just an upside-down U. Of course, these aren't perfect drawings, but just bear with me here, okay? One thing that's true about parabolas is that they are all symmetrical, meaning that if you have the vertex, which the vertex is at the base, or, in this case, it's at the base. In this case, I would say it's at the top, okay? If you draw a straight line through that vertex, a parabola is symmetrical on either side. Okay, symmetrical means that if I would fold this piece of paper on that purple line, that it would rest on top of each other on the other side. Okay, to kind of reiterate what I'm saying, if, for instance, what I just drew in blue was wet paint, and I folded this piece of paper on the purple line, it would fold over and create the green line. The wet paint would come over here, and it would be completely symmetrical, okay? Now, this line here that goes through the vertex is called the axis of symmetry. Axis of symmetry. I just put axis of sim, okay? And that will always be at x equals the x value of your vertex. X equals is always a vertical line. Okay, so if you knew that your vertex of this parabola was, for instance, at, let's say, 3, 1, then the axis of symmetry would be the line x equals 3. Okay. All right, let's kind of go to this is a little bit of guided notes here. You don't need to have this, obviously, but today we're going to learn about the vertex form of a quadratic. Okay, this is kind of you can pause the video and read all this right now, this box here. But let me just summarize this by saying that these are just inside-outside rules, okay? The A value is your coefficient. That will either stretch or compress. Let me give you an example here really fast so everybody can feel comfortable here. Okay, if I just ask you about inside-outside rules of this parabola, hopefully inside -4, you would say that moved the graph right 4. Outside +6, you would say that moved the graph up 6. And it would be stretched by 2. Okay, so we've already learned this stuff with inside-outside rules. If I asked you where the vertex of this parabola was, since it went right 4, up 6, I think you would know that the vertex is at 4, 6. Okay. All right. And that's basically all that's happening here. Okay. Just remember inside outside rules. Your vertex is at 4, 6 because it's inside's opposite. Okay. Just erasing this for a second here. Okay. So for each of these graphs, we're going to list all these important details here, okay? So first of all, the vertex of this equation would be at 2, -3, which means the axis of symmetry is at x equals 2. We just talked about that, okay? To find any intercept, well, you can see this. Well, I'm going to show you a different way to do that in 1 second, okay? This one would, of course, be opening up. It would be opening up. All right, now let me tell you something else here, because it's going to ask you these things, okay? If your vertex in this equation, see how the vertex is at the bottom of the parabola? This is a U-shaped parabola. This means that the vertex is a min. It's a minimum. It's the lowest point on the graph. Now, however, if your parabola looks like this, if it's flipped upside down, then now your vertex is a maximum. Okay? All right, so vertex minimum when it's on the bottom, maximum when it's on the top. Okay, if I wanted to write the equation of this parabola like it's asking me down here, okay, I would know that I just need to use my inside-outside rules. Okay, so to get my vertex over right 2, I would need -2 on the inside. It's down 3, so it'd be -3 on the outside. In number 2, my parabola is, its vertex is at -2, 4. Its axis of symmetry is at x equals -2, of course. It's opening down this time. Okay, now to write the equation of this, there's just going to be one slight change. This parabola is opening upside down. We need a flip. If you remember our inside-outside rules, how do we get a flip? We put a negative out front. Now, since the vertex was moved left 2, it's over here at -2. I need +2 on the inside, and I need +4 on the outside to move it up 4. Okay, now we're going to work the other way. Now we're going to graph things that they give us, okay? We're given the equation this time. So the vertex of this one, since it is at since it's -1 on the inside, inside's opposite, so it's +1, 4. The axis of symmetry is, of course, x equals 1, the x coordinate of my vertex. Okay, now, how do I know if this is going to open up or down? Well, I look at the coefficient. If the leading coefficient, meaning the number in front of the parenthesis, is positive, then it's a U. It opens up. If the leading coefficient is negative, then that's a flip and it will open down. So I know that this one opens up. Okay. All right. Now, sorry, I lost my train of thought. When you graph these, okay? I'm going to let you use your graphing calculator to graph these. It'll be pretty easy. Since a parabola is symmetrical, I want your vertex to be in the middle of your t-table. These are x, y's. This is a t-table. Okay, you need 5 points. So now I need 2 numbers less than the x value of the vertex, 0 and -1. 2 values greater than the vertex, 2 and 3. Okay, and now, hold on. I'm going to bring up my calculator. Where's that calculator at? Here it is. Okay, now what I'm going to do is I'm going to go to my y equals button. I'm going to type in this equation, parenthesis, x -1, close it, squared, +4. And now look at the blue up here, the word graph, my 5 buttons along the top of the calculator. The blue, I can hit the graph and I can look at it. Okay, but if I hit second in graph, I get the blue word table. And now here is a t-table of values. Okay, now look which ones I want. Uh-oh, lost it. I want those that you see right there, -1, 8, 0, 5, -1, 8, 0, 5, 1, 4, that's my vertex. Okay, 2, 5, 3, 8. Now, do you notice the symmetry? See how this is symmetrical? And I can graph these, 1, 4, dot. It's kind of hard with this big pen. 2, 5, 3, 8, 0, 5, -1, 8, and I've graphed the parabola. Let's do another one. Let's do this one. Okay, my vertex, inside's opposite, is at 3, -2. The axis of symmetry is at x equals 3. This one opens down. Why does it open down? Because the number out front's negative. So I know this one flips over like this, looks like an umbrella. Okay, so now I'm going to write my t-table. I know that I want 3, -2, the vertex to be in the middle. 2 numbers below that are 2 and 1. 2 numbers above that are 4 and 5. Okay, I go to my calculator. I clear it out and I type this in. Negative 1/2, which is 0.5, parenthesis, x minus 3, close it, squared, minus 2. I can hit graph. Whoops, I messed it. Did I mess that up? Yep, I forgot the minus right here. X squared minus 2. I can see what that looks like. Okay, now I can go to my table, second and that word to forget table. And here at 3, okay, this is where I'm at. There's my vertice. I need 2 comma negative 2.5 and 1 comma negative 4.
Here in about 20 seconds. If you haven't logged on, please log on now.
Going back to my calculator here to check out those values, I've got 4 comma negative 2.5 and 5 comma negative 4. Again, notice the symmetry on each side of the vertex. And now I can graph this. 3 comma negative 2, 4 comma negative 2.5, 5 comma negative 4, and it's the same. I'm just plotting the points here. Okay, now in this, would this vertex be a max or a min? It's a max because it's the highest point. Okay, all right, I think that's good for now. It's a quick introduction. I'll teach you more face-to-face tomorrow, okay, because there's lots of types of problems, and I don't want to waste your time doing one of every type and have a super long video, okay? So hopefully you caught on a little bit to this and how it relates to your inside-outside rules that we've learned before, all right? See you guys.